What's going on, linear algebras? Welcome back to another video. And in this one, what we're going to do is define and work with the transpose of a matrix. So let me go ahead and start things out with a very exciting definition. If A is any m by n matrix, then the transpose of A is defined to be the n by m matrix that results by interchanging the rows and columns of A. So basically what that means is that all rows in the matrix A turn into columns of the transpose, and in a similar vein, all columns of the matrix A turn into rows of the transpose. The notation that we're going to use to indicate the transpose of a matrix A is A with a superscript of capital T. All right, so let's go ahead and work out a couple of examples to illustrate this idea. In this example, that was my cat Luigi, by the way, in case you heard that. In this example, we're going to find the transpose of each matrix and then determine the size of each. So in example part A, we have a matrix A. It appears to be a 2 by 2. So when we go to find the transpose, that should be a 2 by 2 as well. Let's go ahead and write out the notation for transpose, capital A for the matrix A, and then as a superscript, capital T. Now, I'm going to open up some matrix brackets there. And here's how the transpose works. You can either go from rows to columns, in other words, turn each row into a column, or you can turn each column into a row. I typically like to do the latter, where I turn each column into a row. So for example, the first column in this matrix A has the entries 1 and 3. Those two entries are now going to be the first row in A transpose. So 1 and 3. All right, I suppose we could close off the matrix brackets now. All right, so now we're going to work with column 2, which has entries 2 and 4. Since that's column 2 of the original matrix, in the transpose, it's going to be row 2. So in row 2 of this matrix, we'll have the entries 2 and 4. All right, now let's determine the size. Well, I think once we have the transpose written out, it's clear to see that it's also a 2 by 2. All right, let's work another example. We have a matrix B this time, and the size of that matrix appears to be a 3 by 2, so we know just based on the definition of the transpose that when we form the transpose, it should be a 2 by 3. All right, well, let's go ahead and write out the transpose notation, capital B, the superscript capital T. And I'm going to go from columns to rows in this one as well. So I'm going to take all the entries in the first column. All right, since those are the entries in the first column of the original matrix, those are going to be the entries in the first row of the transpose. So I'm going to write 5, 7, 9 going horizontally or from left to right. We have one more column, and that's column 2. Column 2 in the original matrix B is now going to get turned into row 2 of the transpose. So in row 2, let's write the entries 6, 8, and 0. All right, and that's B transpose. Last but not least, we're going to write the size out. And you can see that in the matrix B transpose, there are 2 rows and 3 columns. So the size of B transpose is a 2 by 3. And there you have it, 2 examples where we're forming the transpose. And that's it for this video. Of course, if you have any questions, feel free to reach out to me. Otherwise, I look forward to seeing you in the next one. Thanks again, Linear Algebros.